All right, so let's look at this other one. And let's kind of do sort of all the steps if you wanted to work along with me. Okay, so it's a rational function. How do we look for horizontal asymptotes? We look at the ratio. So we've got 3x over x cubed, which is 3 over x squared. That goes to 0 as x goes to infinity. So we know y equals 0 is a horizontal asymptote. Okay, let's factor 3x plus 1. Then we've got factor out an x squared plus 6x plus 5. So we've got 3x plus 1, x plus 1, x plus 5. So let's stop here and let's see what are the special numbers to consider. Okay, what makes this 0? X equals -1. What makes the denominator 0? X equals 0. X equals -1, but we have that on our list. And then we got x equals -5. Okay, now we're going to reduce, and that'll help us figure out what those special numbers are. Okay, so we have, so the x plus 1's reduced. So we got 3x plus 5. So these are the numbers that you can't get an output for. Okay, let's see. So if we do these two, they still make the reduced function be dividing by 0. So you know that these are vertical asymptotes. Okay, versus if you look at x minus 1, you can put that in the reduced function and you will get 3 minus 1 plus 5, which is -3/4, which tells you the limit is -3/4, but the output doesn't exist. So you know you've got a removable discontinuity. Okay, now let's figure about the sign chart. Okay, I'll switch back to my nice blue pen. Okay, so you're going to make a number line. I'm going to put all these special numbers, but put them in order. So the smallest number is -5. Then we've got -1. Then we've got 0. We know at -5, no output, vertical asymptote. We know at -1, no output, that's removable discontinuity. We know at 0, vertical asymptote. Okay, so we've got 4 separate regions. Okay, let's see. And now you can use the reduced. So let's make our template. 3 over 2 factors. 3 over 2 factors. 3 over 2 factors. 3 over 2 factors. Okay, let's grab my magic pen. All right, let's see. So let's think about this one first. That is at 0. If you pick a number bigger than 0, that's positive. If you pick a number less than 0, that's negative. Okay, next one. Okay, let's look at this factor. That's 0 at -5. You pick a number bigger than -5, like a million, like that's going to be a plus number. You pick a number to the left of -5, that's going to be a negative number. Okay, so you got plus, 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 and then this part is negative. Okay, now let's draw. We'll put all those together. We'll make our graph. You ready? Okay, so we have, here's our graph. What numbers do we need to put on? We know we've got a horizontal asymptote of y equals 0. Okay, 1, 2, 3, 1, 2, 2, 3, 4, 5, 6. What else do we know? We know we've got a vertical asymptote at -5. We know we've got a removable discontinuity at -1, and we think we're going to get to -3/4. So you kind of plot that like a point. So -1 down 3/4. Okay, and then we have a vertical asymptote here. And now let's do each of the pieces. Okay, so from here to here, we didn't summarize. Okay, so this would be a plus number. Looking at these three signs, plus number, and then I need a minus number, and then a minus number, and then a plus number. All right. Okay, so let's see what we got. So in this last region, we know we're positive. As we push right, we're going to explode up. As we push left, we're going to kind of level out. So we've got some kind of curve like this. Comment on the asymptote. Okay. On the next group, we know this whole thing is negative till we get to here. So we're pushing towards this asymptote. So this has to be negative. And again, I don't know the highest point there. That's okay. We just know we have to go through this point. It could look a little different. That's all right. We're just kind of getting the general behavior. And then in the last group, we're always positive. So we're going to level out coming here, and we're going to push left coming there. Awesome.